It's like right here, there's a power line here.
We're going to start the
Yeah, like this
show.
one, and then this end is like 20, 25 feet from the power line.
Yeah, must be.
It's a really good reflection.
Well,
Well, I'm reaching Oregon and Southern California and
that-
Colorado.
And that's west?
That's west of me, yeah. Everything that I'm reaching Puerto Rico to the east. And that's
could be that
Oregon.
you're just the right distance from it, that it's reflecting and adding just like a Yagi.
That could be.
Yeah, the backside of your beam.
Well, it is a beam, sort of. Okay, we're going to finish up the last one of sub element 4 that we didn't do last week. This is kind of a cleanup session. Get ready for the really fun stuff next week.
Yeah.
Rules and regulations.
Oh, but that's probably easy compared to some goes.
It depends. It's all memory though. Where I only have to remember a few equations, I can drive the rest. So I don't have as much trouble with the math part of it. The memory part is a different issue. Okay, so talk a little about system noise and appliances and DSP noise reduction, a few things that I wasn't aware of that I learned in going through this. So one of the big problems that, especially on the lower bands, is atmospheric noise, which is very wide band, and things like noise blankers, even though they work well on wide bandwidth noise, they don't work on atmospheric noise. They're impulse, and all they do is attenuate the receiver for a period of time. So they just kind of blank it out. Now, the last one, I don't know if anybody has experienced this, but I don't quite understand the effect where when you're using the noise blanker, as far as the exam's concerned, it can make nearby signals appear wide. I have no idea what that mechanism is.
Yeah, I didn't put anything on that either.
And I tried looking up stuff, and it's kind of like, well, that's the answer. But why it works, I don't know. But you know, bottom line is the stuff in red is what you need to remember.
Does it suppress it in the way that the method it suppresses it may be widened?
I don't know. I hadn't researched it enough to try to figure out. And it says may appear, not that it actually makes it wider. So, and I don't know how something sounds wider. I don't know. So, question is, which of the following signals might a receiver noise blanker be able to remove from desired signals?
Here across a wide bandwidth.
So
Baker?
one thing I have seen is when you take like a notch filter, you take out a super strong signal,
Right.
you get all this splatter all the way out.
You can, yes.
The splatter on
Because of the notch itself is going to do harmonics.
Yeah.
Because it looks like a square wave.
Yeah, so I see that a lot. It just splatters.
What undesirable effect can occur when using an IF noise blanker?
Nearby signals excessively wide.
Charlie sounds good.
Yeah. And we don't know why, but sounds good. Okay, noise reduction. And I guess I learned something about my 7300 having some other noise reduction features I didn't know about, like the automatic noise filter. If you hold the button down long enough, you get a different menu, and you can set it for auto or manual. But with DSPs, either external, and what the picture is a commercial version external to the radio for people that don't have DSP type radios that does all that kind of filtering, and you have a lot of adjustments on it. But it can reduce broadband white noise, ignition noise, and power line noise, which would be great. I guess my 7300 does it a little, but I'm 20 feet from a power line, so I get a lot of power line noise on the lower bands. Which of the following types of noise can often be reduced with a digital signal processing noise filter?
Delta.
All of them. Oh, okay. Some have an automatic notch filter, or an ANF, which can magically recognize signals and move the notch to filter them out, kind of center it. One of the issues is it can think a CW signal is an interfering signal and notch it out. There's a picture of what the passband looks like with the notch filter. And you can see it just really takes it out. And you kind of assume there was something there that is filtering out. What problem can occur when using an automatic notch filter to remove interfering carriers while receiving CW signals?
Alpha.
Removal of CW.
Yeah. Anybody here do CW?
Yeah.
Oh, you do? Are you aware of this?
I'm very selective when I use my notch filter.
Well, this
I
is
make
automatic
sure-
though. You put it in automatic mode, or
I
you have,
don't use on
oh, okay.
anything.
Old school.
No, I have an 890. And I just use the notch filter, and it's got 3 settings. It's got narrow, wide, and narrow, medium, and wide.
Okay.
It'll take out a jump. It's great.
Okay. So even though you can, particularly with DSP type filters, you can get some very effective filtering. If you could eliminate the source, would be better than trying to filter it out. So this is talking about if you're hearing a roaring, buzzing sound that comes and goes, it could be some sort of thermostatic control device. I have one of those, a heat chamber that keeps my 3D printer filament dry. And when it's got a thermal switch in it, and when it turns the heater on and off, you can really hear it on the radio and on my Bluetooth hearing aids.
That's that's funny. It says arcing contacts and thermostatically controlled. It has nothing to do with thermostatically.
No, but it's the fact that the contacts are breaking, so you're going to get an arc.
Right, but what I'm saying is, it's funny that it's mentioned here about reducing electrical appliance noise. My air conditioning, the unused wires to my thermostat act like an antenna and cause like, I think it's 10 over.
Yeah.
And I grounded those additional lines and went away. So, you know, it comes outside that cage, you know, and is an antenna
Okay,
to the thermostat.
doorbell, yeah. Well, most of the thermostats, unless it's electronic one, have a thermal switch in them too. So that's either closing that loop or opening it, which is, even though there's not much power there, you know, it's going to change the impedance of the loop. Defective doorbells or transformers and illuminated advertising displays. I'm assuming that's like neon. They don't really get specific, but I would think neon signs would do it. They didn't list LEDs and LED ballasts, which nowadays are the big ones, especially the ballast. And from,
noise.
and from what I understand, you can get the replacement LED tubes that don't require ballast, and they don't generate nearly as much noise as the electronic ballast.
The little touch devices that turn on light bulbs scream out noise.
It's all kinds of noise. Okay, so one of the solutions of trying to find out where it's coming from is to operate your radio on battery and see if you're still picking up the same noise, which would take away noise coming in on the power line to your power supply. If it is coming from a motor, you can install a filter similar to the one I'm showing here, or just putting bypass capacitors across the input. This is a little more, it's got bypass capacitors and some inductors in it, so it's kind of like a double pi network. What might be the cause of a loud roaring or buzzing AC line interference that comes and goes?
All.
All of those. How can radio frequency interference from an AC motor be suppressed? I'm going to turn.
I'm going to say bravo.
Well, I think you might be right. These are all retreads from the general and tech exam. Common mode noise. You can have common mode on your, even they don't talk about feed line. If you've got any unbalance on your antenna, you're going to have a current on the outside of the shield, which is called common mode, either going in one direction or the other, depending on the unbalance. If you've got multi-conductor cables, if they're unshielded, you can get common mode current that's flowing pretty much equally on all the conductors. If it is a shielded multi-conductor cable, you can definitely still get current on the shield. They talk about possibly getting it on the conductors also. I guess that's true because it's not coax. The reason you don't see it on the inside of coax is because the electric field forces the center conductor and the inside of the shield to be the same, on opposite. So any difference current has got to go on the outside. And then one of the things that was in the book is to eliminate it, make sure that you ground the shield on one end, which works on audio stuff. I always was taught it didn't work on RF because of the capacitance. You still got a connection on both ends, whether you ground both ends or not.
Which end do you ground? I mean, does it make a difference?
Source.
Normally.
Ernie says source.
That's what
Okay.
PC boards.
Well, that makes sense.
Yeah.
Which of the following can cause shielded cables to radiate or receive interference?
Well, it must be B because that's the only one that says common mode.
That's true. Common point isn't the same thing. Okay, what current flows equally on all conductors of an unshielded multi-conductor cable?
Again, the common
Bravo.
All right, in automobiles, at least used to be, the main source was an alternator. I'm not sure that's true with the Tesla or the electric cars. I suspect they have a lot of noise sources. One of the things you used to do is put one of these capacitors there on the alternator. Now they talk about a coaxial capacitor. I kind of remember seeing them decades ago. The only one I could find is this kind of expensive whiz bang, which is a coaxial capacitor with the ground in that box. Probably a little pricey. Was that you knocking, Michael?
Yeah, somebody's at my door. I'll be back.
Okay. I just thought maybe they're trying to get in. So how can conducted and radiated noise caused by an automobile alternator be suppressed?
You said coaxial capacitors, that's difference there.
Yeah. Yeah, coaxials are like feed-through capacitors, which they used to use in a lot of electronics where you went through a bulkhead or a shielded, and it was, you know, like threaded thing you could screw in there and actually had a conductor all the way through, but it acted like a capacitor to the outside. Let's go with Delta.
A gets rid of all the noise too.
What does?
A does also. Turns off the radio, they get no power.
Yeah, that was. Okay. Personal computers and other digital devices can be noise sources. Are you being attacked?
I'm sorry. I'm back.
Or did you get a big package and you're wrestling it in the house?
No. Oh,
Okay, so if you see an unstable modulated or unmodulated signal at specific frequencies, and I see these little pickets about every 10, 12 kilohertz from something.
birdies.
Yeah, I haven't figured out what they're coming from.
I see them periodically that run across the screen, you know.
Oh, that's different. I see that one too.
Yeah.
And it's a nice looking carrier, and it just
Yeah.
goes further quickly. Somebody's scanning us, I guess.
The other one, isn't that from the one that's every 12 or 15 kilohertz? That goes all through the lower bands.
Right.
And I can't use the lower bands because it's so bad in my house. The power companies and all their electronic metering that they do now.
Yeah, but that's all low frequency. Well, of course, it could be harmonics.
I don't know what it is, but that's the only thing I can think
But
of.
they're down at the, what, 2,200 meter or something? That's why
Yeah.
we're restricted down there.
Right,
because
we're
of the power
restricted to
companies.
1 watt or less effective radiated power.
Yeah. So what's one type of electrical interference that might be caused by a nearby personal computer?
You said
Thinking Charlie.
unstable modulated.
Yeah, whatever unstable modulated is. I can't say I can see the difference if I turn my computer on or off. And there's nothing, well, it's a tower, but so it's got a metal case, but still lots of holes.
Probably not that one.
Okay.
AC adapters, I wonder how much noise those things.
Oh, the little wall warts. Some of them are, I understand, are quite noisy.
Yeah, they are.
Especially the Amazon made in China. Of course, they're all made in China. But, some of the cheap ones.
Not the really good Chinese ones.
Well, let's face it, some of the stuff from China's got to be good because virtually everything made there. So even the good stuff, I mean, the ICOMs and the Asus are made in China.
So don't blame China, blame the manufacturer that specified what they required.
Yes. When they say, give me this for the cheapest price, you get what you pay for.
You get what you pay for.
Okay, this one is talking basically about intermods between stuff like rusty metal joints, which I read about a lot. I don't know. Have you ever experienced intermod from a corroded metal joint somewhere or
No,
pipe?
no,
Michael?
Don't know.
Yeah.
I just believe them.
they had it on the repeaters. Some of the repeaters, UHF repeaters they had.
Yeah.
I had, when it rains, it would get moist and then there'd be interference, intermod, but the one over there on Woodstock Hospital. Had a problem there at one time.
Well, I can
That was the
understand
antenna.
technically how it
That
works,
was
but
on the antenna.
I wouldn't think it would, but
It's at a
it would
different-
regenerate much noise, but
It's at a different frequency. It completely generates a complete.
well, it's going to be one of the harmonic products.
Right.
So
The
remember
intermodulation.
from last week, it could be very close to the two that are causing it. Okay. Because it's going to be this, all the sum and differences of all the different frequencies and all the harmonics. What could cause local AM broadcast band signals to combine to generate spurious signals in the medium or high frequency bands?
Yeah, the corroded metal joints. Yeah.
Wonder why they picked AM, I guess because of the power. Because AM stations are putting out what, 100,000 watts?
It's also the frequency too.
Yeah.
Of the AIM band, probably.
Yeah.
Railroad tracks used to cause that.
What?
When they weren't welded,
Stop recording.
you would hear it.
Really?
Yeah.
But that's just